A 7 1/4 inch gauge Sweet Williams steam locomotive part 39, painting the outside of the boiler cladding using HMG Satin Black enamel paint. Then I fitted the Firebox cladding to the boiler, but unfortunately there is a slight problem, and I need to make some special parts. Perfect outside painting weather, a gentle breeze and no rain. The paint I'm using for the outside of the cladding is HMG Satin Black, and I really do like this stuff. I like the way it goes on, I like the way it dries, and more importantly, I like the way it looks when it's dry. Just in case you're wondering, the painting clips are running at 400%, 4 times normal speed. And in no time at all, one of the sides of the Firebox cladding is painted. Now for the other side. As I've just mentioned, I really do find this to be a very high quality paint, and it's not prone to running or sagging. It just goes on there and dries quickly. The noise you can hear in the background is a jet flying overhead. I live quite near to an RAF airbase, and I get used to the sound. In fact, the engine sound of a Typhoon is quite amazing, almost as good as a Spitfire engine. Well, maybe not quite. The Merlin engine still takes some beating from a sound point of view. Running at 4 times normal speed, the painting job was soon completed, and 24 hours later I fitted the Firebox cladding to the boiler. The Firebox cladding is held to the boiler using a boiler band at the front and this beaten copper part at the rear. It's starting to look good now. This has been a long time coming. I really have had to wait until we got decent weather so I could paint the parts. When I look at this boiler cladding, I can't help but think that I would not have made it this way. Normally when I clad boilers, I make an accurate cardboard template, then transfer the shape onto a suitable piece of cladding material. This is a bit of a mess, quite frankly. It splits in the middle and it's visible, and the holes in the cladding are not in the right place for the boiler bushes. In a previous episode, I showed how I enlarged one of the holes to fit. This is a shot of the barrel cladding, and again it's made in 2 halves instead of being one continuous wrapper. Unlike some of my viewers though, I don't like to be too picky about things. This is the way the engine was built, and by the time I've finished it, it will look a whole lot better than it used to. Here I've temporarily screwed the turret in place into one of the bushes, and as you can see, it looks very messy where the bottom nut meets the boiler. I think I have a solution to this problem, and in this episode I'm going to start the process of making some special fittings. I'm going to make 3 stepped washers, and the first thing I need to know is what is the external diameter of the washers going to be. The external diameter needs to be large enough to cover the gaps that have been caused by the enlarged holes in the cladding, and make everything look okay again. That's the plan anyway. Question is, which material should I use? Here's a piece of brass, but there are 2 things against using this piece of brass. One is the fact that it's a piece of brass, and in this area of the boiler, with the turret and safety valves, there is already an excess of brass-coloured metal. And also this piece of brass is a bit too small for the 3 stepped washers that I want to make. This is a piece of stainless steel. I know it's stainless steel because it's not magnetic, and even though it is infinitely more difficult to machine than brass, I'm going to use this to make the parts. The first thing to do is to face across the front to see how it cuts, and it's a hard piece of stainless steel is this, but it does machine quite well with this carbide tip insert tool that I modified recently to fit the tool holder in the Boxford lathe. I need to turn quite a bit of this metal away down to the diameter set by the digital caliper. I'm only taking fine cuts because I want to see how fine a finish I can get with this tool that's now getting slightly blunt. I'm using the digital caliper again to measure the thread on the end of the safety valve, in order to select a suitable drill bit for drilling the hole, but the bad news is I do not have a drill bit of this size. I have this drill bit, which is 5/8 of an inch in diameter. The Red Cross says there is something wrong, so what's wrong? 2 things. The spindle speed of the lathe is too high, and I really need to drill a pilot hole first. This should be a good size for a pilot hole, And by the way, I'm not running the lathe really fast, the video is running fast just to get through the process. With the pilot hole successfully drilled, I return to the 5/8 of an inch diameter twist drill. And you can hear by the sound of it, the lathe is going too fast, and in no time at all it grabs the drill. When I put the lathe in back gear, which slows it down, as you can see, this 5/8 of an inch diameter twist drill bit cuts perfectly. The strange thing about a lot of the drills that I have is that I got them from a local scrapyard to where I used to live, and this scrapyard was local to a very well-known machine tool manufacturer in a place with the curious name of Heckmanwijk in West Yorkshire. Some of this tooling that I bought from the scrapyard at that time was absolutely perfect, and to this day it still is. All of the drills and reamers that I have above 1/2 inch are Morse taper number 2, and I've never broken one in 45 years. And the tools are still sharp. I don't think they make tools like they used to back in the day. Now the piece of stainless steel has a 5/8 of an inch diameter hole in the middle, which is not big enough for the thread on the safety valve. Parting off a piece of stainless steel with a very small parting tool in quite a small lathe is not something I want to do. I could use my Smart & Brown lathe for this operation, but no, I would probably still break the parting tool. The solution to the problem is simple. Remove the part from the chuck and put it in the bandsaw. Although it may not be very accurate, I can slice up the piece of metal into 3 parts that I need. What I'm doing first though is cutting halfway through on the mark made by the parting tool. There is a reason for this, because once I've shortened this piece of metal, there won't be very much left to hold in the bandsaw's vise. So the final cut will be the quickest one. Here I'm cutting off the second piece, and the blade is cutting anything but square. This soon got very boring, so I went into the outer part of the workshop to repaint the flywheel from my small showman's engine. I've already done this job once, and if you've been watching the series My Small Showman's Engine Needs Some Repairs, you will have seen this already on the previous incarnation. Making these 3 special stainless steel washers, it would have been much easier to do the entire job in my large Smart & Brown lathe, but then again, this Myford is more like a home workshop lathe, so I'm going to use this for the next job, which is to bore the holes slightly larger in order to accept the safety valves and the turret. The part in the chuck looks a bit wobbly, but it isn't. It's because the bandsaw didn't cut the part perfectly square. This is the first piece that I cut off the bar, and one side was the part that I faced, and that runs true. There's still quite a bit of fiddly machining to do, and I think I'll probably use the Myford for most of it. But that will be in the next episode in this series. For now, stay safe, stay healthy, thanks for watching, and I hope you found it useful. Please take the time to visit my Mainsteam Models website and click on the section of the website that says Video Playlists. And by doing that, you can find other videos that you may like to watch. And by using the playlists, you can actually watch the videos back to back.